Hi everyone. Today I'm going to be going over StartCraft, which is an introduction to Broodwar API programming for StarCraft Broodwar. So just a couple of quick notes before we get started. For anyone watching this on YouTube, this video is being live streamed on Twitch right now. So if you hear me interacting with the chat at some point or answering questions, that's where those are coming from. And any links that I mention, like for example, the GitHub link, or links to other resources will be down in the description of the YouTube video, so please check that out. So for anyone who doesn't know who I am, I'm Dave Churchill. I'm a professor at Memorial University, and I've been running the StarCraft AI competition for, 10 or 11 years now, so I have a fair bit of experience with it. And what I've done recently is I'm teaching this course, which this video is actually a lecture for my course in game AI programming. So what I've done is their final project is actually to write a StarCraft bot. And so in order to help them out with that, I've written this GitHub repo called StartCraft. Very clever, right? So StartCraft is intended for you to get started with StarCraft AI development and programming as fast as possible. I have a couple of other videos out there on my channel about like getting started with other bots like UAlbertaBot, for example. That's a far more fully developed system that is a bit more complicated to set up and run. It's still pretty easy, but it's definitely more complicated than what we're going to be going over today. So if you're interested in a more fully functional system, go watch that video. But if you are completely brand new to StarCraft AI programming, please watch this one. And if you have absolutely no idea what StarCraft is, or if you're intimidated by getting into RTS games, the last video that I made, which will also be linked in the description, is me going over a complete beginner's introduction to StarCraft, what the game is about, and a little bit of introduction to the Broodwar API programming interface and related technical issues. So please, if you absolutely don't know about StarCraft, go watch that video first. If you know about StarCraft and you just want to get into the programming, actually that video is still pretty good because it gives you some technical details about the Broodwar API, etc. But this video is going to be all implementation specific about how to install StartCraft and start programming. So there won't be any boring PowerPoint slides today. So first of all, what is StartCraft? It is a very basic sample example bot written in C++ that uses BWAPI, the Broodwar API, in order to interact with StarCraft so that you can write an AI system for the game. As you can see here, the setup instructions are very, very simple. I made them as simple as possible, and I'll go over why they're so simple in a few minutes. But you should be able to get going with this as quickly as you can download the files almost. The only thing is, if you actually want to be programming, so a little note down here at the bottom, if you want to modify the example bot, which is why I'm sure you're here, you must have the latest version of Visual Studio 2019 installed. And the reason why you have to have the latest version and not just any version is that in order to get you up and running as fast as possible, what I've done here is I've actually included the Broodwar API lib files that the project links against. So if you're familiar with C++, then you have the link against libraries. And these libraries are compiled and maintained at the most recent version of Visual Studio. So yes, this is unfortunately Windows only, but StarCraft is Windows only. I will be releasing a Linux version of this later, but it is, as of the time of recording this video, is not available. And you can see here by this update that this video is using Microsoft Visual Studio C++ 16.9.1. If you're watching this in the future, it might be a different version. All right, so let's go back here. And what we're going to do is I'm just going to install this really quick and show you how easy it is to get up and running. So I'm actually recording this in a pretty new virtual machine environment. It's basically just got Visual Studio 2019 already installed. By far the hardest part of this is installing Visual Studio 2019 Community Edition. You don't need to pay for it. It's all free. So I've already got that installed and updated to the most recent version. So what we're going to do now is we're actually going to install StartCraft. So here again, if you're very, very new to StarCraft, StarCraft AI programming, you can look at this video, which is an intro to StarCraft AI that I recorded earlier this week. So please go look at that if you haven't already, or you're unfamiliar. You're completely new to StarCraft and sort of what programming means, or how the units move around in the game and the commands that you issue and stuff like that. Okay, so let's look at the setup instructions. StartCraft comes with a StarterBot written in C++ using BWAPI 4.4.0. This repo comes with BWAPI and uses a program called Injectory to launch StarCraft with BWAPI, so Chaos Launcher is not required. And I'll get into what that means in a second, but first we're going to set it up, we're going to run it, and then I'll explain a bit more about BWAPI and why I mentioned Chaos Launcher here. So the first thing you have to do is download or clone this repo to your computer. So if you have Git installed, you can clone the repo. I don't have Git installed right now, so what I'm going to do is I'm just going to download the zip file, and I'm going to open that. So what I've done is I've opened up that zip file here, and now what I'm going to do is I like to put all of my C++ libraries in a folder under the C drive called Libraries. You don't have to do this, but I enjoy doing this because all of my development is sort of taking place in this one little neat folder. So I'm going to make that C Libraries folder, and I'm just going to drag over this StartCraft main, and main is just the Git branch, so I'm just going to delete that part of it, okay? So I just have this StartCraft folder here. All right, so now I can remove that. And then the second instruction is to download and unzip Broodwar 1.16.1 to the included Windows/StarCraft directory. So what that means is, inside the StartCraft folder, there's a Windows folder. Inside that Windows folder, there's a StarCraft folder. So you're going to click this, and I'm going to open that file. So that might take a second to download. And then I'm going to take all these files and just extract them into that folder. Okay? And you're done. That's the whole setup, other than installing Visual Studio 2019. So that's it. I've made it as simple as possible. Now you can actually run the bot using this bat file, which I've created for you. It's called run C++ bot and starcraft.bat. So we are going to double click that and see what happens. So you can see here that the bot just runs. And so this is the AI bot running. This is the starter bot. And here it is, it's mining some minerals. After it mines some minerals, it's going to build a pylon, and that's about it. It's just got the bot set up to do very, very basic stuff so that you can build on it. It's got some other features built in, like some basic map analysis, but I'm going to get into that a little bit later. I just wanted to show you that, yes, indeed, StarCraft is up and running with the bot as fast as humanly possible. But, of course, you're going to be wanting to do some development, right? So what you can do is you can go into the C++ directory, then to the Visual Studio directory, and I already have these Visual Studio project files already set up for you. So all you have to do is double-click startcraft.solution, and then you are set up and running with the StarterBot. Okay. So if you want to recompile it, you can switch to release or debug mode depending on what you want to do. Then you can right click and hit build, and this should all just work out of the box. So hopefully this works now. We'll just see. So it's compiling all the CPP files, linking it against the included version of the Broodwar API, and there we go. We've got our included starterbot.exe. So before I get into any of the development or the programming, what I'm going to do is I'm going to show you a little bit about how bots work with StarCraft. So I know I included this single command here that runs the C++ bot and it runs StarCraft, but what is this file actually doing? How is this magic happening? So we're just going to edit this to see the command that, that is actually being run. So this is just a very simple bat file, and what it does is, oh, for some reason there's a... Oh, I see. So I wrote this in a different editor, and Notepad does not realize the new lines. So if you open that in Notepad and there's no new line characters, that's why. So let me just edit that and rerun it real quick to make sure that it still works. Okay, and it does, so I'll shut that down. Alrighty. So what this is doing is that it's changing directory into the bin directory, which is right here, and then it's running StarterBot.exe. So it's running the executable for the bot. So let's see what happens when we do that. So when I just start the bot on its own, it's going to sit here, and every second it's going to say game table mapping not found. So what this is doing is that this is using a client architecture, we call it. So your bot is compiled into its own executable, and then when you run the bot, it's going to wait until it connects to StarCraft running BWAPI. So if you run the bot and you see game table mapping not found continuously printing, what that means is that essentially StarCraft is not running yet, okay? So what we have to do is we have to run StarCraft. And if we go back here, oh, I see what happened here. Telling you, Notepad doesn't like nice new lines. Okay, so if we go back into the StarCraft directory, we'll see this is where StarCraft is actually located. So naturally, you might just launch starcraft.exe, but there's a couple of reasons why you don't want to just run starcraft.exe. The first is that StarCraft was written for a completely different operating system with completely different like VGA graphics. It runs in like 640 by 480 resolution, and it's probably going to mess up your monitor settings or whatever. So don't run StarCraft on its own unless you're playing like a single player game and you want to enjoy the campaign or something like that. So what I've included here is this other bat file. And what this will do is in order for, the second reason that you don't just run StarCraft is because you have to run StarCraft with the BWAPI DLL injected. So what does that mean? Well, one way that we're able to actually write code that controls StarCraft is by having a program running inside StarCraft that allows our bot to connect to it. So you don't need to understand all of these details, but essentially you have to do something called DLL injection, which injects the BWAPI library into StarCraft so that our program will actually connect to it, okay? So in order to inject that DLL, what you may have seen if you've done any bot development in the past or you've watched any other of my videos is a program called Chaos Launcher. So the reason we use Chaos Launcher is that you can, with a very nice user interface, you can like click something and then inject the BWAPI DLL or turn it into windowed mode, etc. But really all Chaos Launcher is it's a nice user interface. But if we want to get up and running as fast as possible, we don't need that user interface. We don't need the annoying parts of Chaos Launcher. So what I've done here is I've included a bat file which uses this program called Injectory, which I have included in the directory here, to do the DLL injection for us, okay? So that's why you have to launch StarCraft using this command. And that's because it runs Injectory, and then it launches starcraft.exe, and it injects 2 DLLs, okay? So the first DLL that it injects is this BWAPI-data/BWAPI.dll, and that's so we can actually connect to the bot. And the second DLL is this W-mode DLL, and that lets StarCraft run in a window, which is super convenient for like modern operating systems. So this bat file is going to launch StarCraft, and it's going to inject the DLL, and it's going to, for BWAPI, and it's going to let us run the game in windowed mode. So if I close both of these, and I go back to this run C++ bot and StarCraft, what it does is it changes directory into the bin directory, it starts our StarterBot executable, which waits for StarCraft, then it changes directory into the StarCraft directory, and it's going to run that run StarCraft with BWAPI.bat. So let's just run that. We'll run those one at a time just to see how it works. So here we go, we CD into StarCraft, now we're running our StarterBot, it's waiting for the game to start, and then we go into the StartCraft directory, and we run the bat file, which launches StarCraft with BWAPI, And we can see here that something else happened in our game. And so now the bot is connected. It's playing a game on a specific map. So we've printed that out inside our bot. While you are coding your StarterBot, if you use any like standard cout or printf, it will actually print out to this console. So that's a really nice debugging feature, is that you actually have a console that you can print out to while you're using your bot. So that's how that's sort of the architecture that's used in order to write your bot and connect it to StarCraft, and why you're probably going to see game table mapping not found. Okie dokie. Now let's quickly go over, before we start programming, I want to go over just a couple of the BWAPI settings. So when I run this run C++ bot and StarCraft, it does those two things that we just said. But you can also see that it launches StarCraft and it goes through the whole menu for us and just launches the game right away using the Protoss race on a given map. So how is it able to do that? Well, I'll show you how it does that. Inside the StarCraft directory, there's a BWAPI data folder, and inside that BWAPI data folder, there's this BWAPI.ini file. So we can just edit that. So these are the settings that the Broodwar API actually uses when it's running. Now here, the first setting talks about these DLL files. This is kind of a legacy feature if you compiled your bot to a DLL, which we are not doing. So you can completely ignore these. They have nothing to do with how we're running things. The next option says tournament. And if you're running a tournament, sometimes what you want to be able to do is have like a God mode program running that like doesn't allow bots to cheat or type in cheat codes, etc. Or it's able to time the bots or do other referee type things. So if you are running a tournament, this is where you would specify that DLL file that you want to inject, but we're not worrying about that. And the next one is very important. So this is the auto menu feature. So here, if I go from auto menu equals single player to auto menu equals off, and then I come back and I rerun our bot and StarCraft, what you'll see is that StarCraft no longer goes through the menu for us, okay? So if the auto menu is off, which you may want, then you would have to go through single player, expansion, you would select your character, you would go play custom, then you'd load a map, let's say destination, and then you'd choose a race, and then you'd choose a race for your opponent, and then you'd click OK, and then the game would be starting. All right. But that like 30-second process of selecting all of those settings, when you're in rapid development and you're iterating on your bot, that's actually really annoying to go through. So you can change this to single player. And then what it will do is it will auto menu for you and go right into the game. And it will use the settings in this file that we're about to go over in order to do that. So the character name that it uses, I've just set that to StarterBot. It absolutely doesn't matter. It's just what the character name is, what shows up as your name when you're actually in the game. The next option is this pause debug. What this will do is if you're using a DLL bot, it will pause the game until a debugger is attached, but you absolutely don't need to worry about that because we're not using the DLL architecture. This is for LAN mode settings. We don't need to worry about that right now. The auto restart feature is pretty cool. What it will do is if the game ends, so if you win or you lose, so if the game ends for any reason, it will auto menu again and restart the game with the same settings. So you can turn auto restart on or off. Next is the map setting. So what this will do is it will select the map for you. So for example here, I've included a bunch of maps in the Broodwar directory from the AI IDE competition, as well as the COG competition and the SSCAIT competition. So these are just good maps for the bots to play on. And you can kind of specify a regex here so that you can iterate through multiple maps. So for example, if I specify this, then essentially that will select any of the maps in the directory. And so with auto restart on, what will happen is it will go to the next map in that regex whenever it restarts the game. So that's a really convenient feature as well. The next thing that we're concerned with. This is only if we are, this game setting is only if we're concerned with joining multiplayer games or LAN games, which we're not going over in this tutorial. Map iteration. So up here, when I said that this will match a regex, and so there's 10 maps in this directory, this will load all 10 maps. This will tell you how you actually go through those maps when the auto restart function is on. So if you choose random, it will choose a random map that matches this regex. And if you choose sequence, it will go through them, I believe, alphabetically. So you may want to choose sequence, I think, or random, depending on what you want to do. Here, this will select the race for you in the auto menu. So if it's Protoss, we're going to choose Protoss. Here is the enemy count. This is only used in single player games. So the StarterBot will only work right now if you're playing against a single opponent. So just keep that in mind. Or it might work for multiple opponents, but it's not guaranteed to work for multiple opponents. Here you can set the enemy race. I'm just going to leave that on random. And you want to make sure the game type is set to melee. StarCraft has a bunch of different game types. There's like free-for-all, melee, there's like use map settings, and essentially what melee does, melee is the standard version of StarCraft, where you start with 4 workers, a command center, and an overlord if you're Zerg. Okay, so just, I've never changed that from melee, unless you're doing some custom map for like research purposes, which I haven't done in a very long time. You can also specify a directory and file name for your replays, so it will automatically save the replays of every game. Also, what else are we worried about here? This windowed equals on. I would just set that to off, actually, because we are injecting a separate window mode DLL that actually, if this is on or off, it doesn't matter, because we're using another DLL that overrides that setting. And if you do want to use the BWAPI windowed mode, it's not as nice as the one that I've included. That's why I have it there. You can also turn the sound engine on or off, so this will mute all game sounds. And what else? You can also specify a random seed if you don't want there to be unexpected randomness. Okay, so for example, there are some things in StarCraft that do depend on randomness. For example, the starting location within a map is depending on randomness. And if you want you to start in the same location and your opponent to start in the same location every time, you can actually specify an integer seed that StarCraft will use for its RNG number generation. All right, so that is the BWAPI settings, and I'm going to just turn that back to single player, and I'm going to run it once more just to make sure that I have all the settings correct. Perfect. Okay. All right, now let's go to a bit of the programming. So in order to start programming the StarterBot, you're going to have, as I say here, Visual Studio 2019. So the most recent version is required because I've included pre-compiled BWAPI library files in order to make this as fast as possible to set up and use. And because I've included those pre-compiled libraries, Visual Studio is a bit annoying in that sometimes if the version is different, you're not going to be able to link against libraries that were compiled in a different version. So I'm going to try and keep this as up to date as possible. And right now, as of the recording, it's MSVC 16.9.1. Okay. So in order to launch this, as step 4 says, we'll go into Windows, C++, Visual Studio, StarCraft.solution. I've already got that up and running. Cool. The first thing I want to mention is that in the settings here of the project, so we go to Project Properties. If we go into Debugging, we're going to see the working directory. And so what you want to do is, I'm not sure why this isn't set already, but if this is, one second, release. If this currently says just project dir, then you want to type /bin in here. And the reason for that is that when we run the executable from Visual Studio, that will set the current working directory of the bot to the bin directory. So that's how you set the current working directory within Visual Studio. Okay, So I'm going to set that for debug mode as well. Perfect. So before we get into the code, again, one thing I did want to mention is that oftentimes when you're developing a bot, you want to be running the bot from Visual Studio in debug mode. And the reason for that is Visual Studio has a really nice debugger. We can set breakpoints, we can inspect memory, all sorts of things. So if you are going to be running the bot from this inside Visual Studio, so I'll just compile and run the bot just to show you right now. Here we go. Why is that not a valid working directory? Oh, I see. We're debugging this together. So Windows bin, oh, I see. Perfect. So I'm debugging this with you. Here we go. It's .. /bin. Perfect. So we're going to change that for both projects. There we go. And now we'll run it again. Perfect. So now you see again, you see game table mapping not found. We are running within the Visual Studio debugger. So if you come over here now, StarCraft is already running from within Visual Studio. So what you actually have to do here now is you just go into the StarCraft directory and then you run the run StarCraft with BWAPI.bat. And what will happen is this will inject StarCraft and it will go through the menus. And now you are running StarCraft, the StarterBot, in debug mode inside Visual Studio, and the game is running on its own. So if we go back here, let me just show you what this offers for us. Oh, by the way, if you stop the exe, you have to stop StarCraft. So I'm just going to do that. And I really quickly want to show you what happens if we set a breakpoint, because it's really neat. So let's set a breakpoint in the onStart function of our bot, and then I'm going to run it again. So it says game table mapping not found. We go back and we run StarCraft so that it will connect. And then the game has just started. Our onStart function has been called and our breakpoint has been set. And now we can go through and we can actually visually debug using the Visual Studio debugger, which is super awesome. So that's why I highly recommend using the client architecture, because it's really easy to set up and run the bot and use the debugger if you want to. Okie doke. So let's go over some of the code here. I'm just going to make this a little bit bigger so that you can see it. Okay. So the first thing we're going to go over is main.cpp. So I want to explain how the bot actually works before we get into the programming side of things. So inside the bot, we're going to have a main function. Of course, all of our programs have a main function. We also have a game count. This is going to keep track of how many games have been run if we're using auto restart. And so the very first line of code is going to be trying to connect to the Broodwar API. So it just says while not BWAPI client.connect. So this is trying to connect to StarCraft. It's going to sleep for 1,000. So what this does is it tries to connect to StarCraft. If it doesn't find it, then BWAPI internally prints game table mapping not found, and then we sleep for 1,000, meaning we wait one more second. Then once we're connected, that part of the code stops, and we've connected to BWAPI, so now we can actually start running our game. So we say waiting for game to start, and then while we're not connected and we're not in the game, we just have to send this update command to our client. And then once we actually get into the game, and getting into the game meaning that like the play mode of the game has started. So we're out of the menus and we're now playing StarCraft. That's when this is in-game is true. Oh my god, that scared the crap out of me. So that was running in the background. Okay. So we call the play game function, and that's going to actually set up the bot and run the bot for us. So let's look at what that play game function does. Well, what it does is it creates an instance of our StarterBot class, and I'll get into the StarterBot class in a bit. And what it does is for each, how BWAPI works is that it's sort of an event-based system. And so there's a number of different events in StarCraft that are going to trigger parts of your code. Now, if this sounds a bit confusing, you don't have to understand it in depth, but I do want to go over it to make sure that you understand how the bot is actually running and how it works. So essentially what it says is that while BWAPI is connected and we are still playing the game, we're going to go over all of the different events that get triggered that call our code. So we can see all of the different event types here, and the most important event types are match start, match frame, and match end. Okay, so match start, that gets called when the very first frame of the game, match start gets called. So what we're going to do when that event happens, we're going to call our bot's onStart function. Similarly, when the game ends, we're going to call the mapEnd function, when the match end events get triggered, we're going to call our bot's onEnd function. And as a parameter to that function, we're going to pass in who won the game. Oh, I just lost the game. Man, I'm playing for so long. Ignore that if you don't get it. So here we have these events. So E, the event, contains the game's winner. So that's just a Boolean that we pass in. And what we do is we pass into the onEnd function whether or not we won the game. If that's false, then one of our opponents won. If it's true, then we won the game. The next event that's probably the most important event, actually, is the match frame call. So the way that BWAPI works is that it is a blocking system. So every frame that happens in the game of StarCraft, it's going to call it's going to trigger the match frame event, and then it's going to wait for all of your code inside this event to happen before it goes to the next frame of the game. So what does that really mean? So here, for example, you can see that when the match frame event happens, the bot's onFrame function gets called. So the onFrame function is basically what we want to do every single frame of the game. So this is all of our updates for all of our units. All of our AI basically lives in that onFrame function. But since BWAPI is actually blocking, then what happens is we don't have to worry about any sort of concurrency or anything like that when it comes to programming this game. So a new frame of the game happens internally in the StarCraft engine. Your code gets called, and then it will wait however long your code needs to run before it goes to the next frame of the game. Okay? So it's not like, if the game is running at 24 frames per second, which StarCraft runs at, if it's running at 24 frames per second, which is approximately 40 milliseconds per frame, your code does not need to run in 40 milliseconds. If your code takes 2 minutes to run in the onFrame function, then it's going to wait 2 minutes before the StarCraft game actually gets updated, okay? So let's just show you what that looks like in practice. So up here, I can get this sleep for 1 second, okay? And I can copy this, and I can bring it down into this function. So let me just put that ahead here. I know this looks a little dirty, but what we're going to do is on match frame event, we're going to sleep for a second before we call our bot's onFrame function. So let's go back here and we're going to run the bot again. So this is going to recompile and run the bot. Okay, so it says game table mapping not found. So we have to go start StarCraft. So we do. And you can see now what's going to happen is that the game is running at 1 frame per second, right? Because our code on each frame of the game is taking a second to run. And so it doesn't matter how long our code takes to run, the game is going to wait for our code to finish. So it's good in a sense that we don't have to worry about that, but maybe bad in the sense that we could actually program our bot really slowly, and if it's in a competition setting, you might get a game timeout or a game loss or something because of that. Okay. Just keep in mind when you're writing your bot that if your bot takes more than a minute on any particular frame, then it's going to, it may actually trigger a loss for your bot and it may disconnect if it takes more than 1 minute. The rest of the events are pretty self-explanatory. So actually, they're not that self-explanatory. So the events are unit show, unit hide, unit create, unit morph, unit destroy, unit renegade, etc., etc. So all of these happen when specific events are triggered on units in the game. So when our match frame code just runs and runs and runs every frame, but for example, let's say we wanted to print out a message to the screen to BM our opponent whenever one of the opponent's units died, right? So we could say like, haha, you suck, whenever we killed one of their units. How would we do that? Well, one way of doing it would be non-event based, where every frame we could keep track of every opponent unit that we see, and then if on one frame of the game it was alive and on the next frame of the game it was dead, we could say something. But that's really annoying. So what we could do is use the unit destroy event. So what this does is inside our code, an event is going to get triggered, which is going to call our bot's onUnitDestroy function. And as a parameter is going to be the unit that actually got destroyed on that frame of the game. So then we could update our data structures accordingly. But yes, don't BM the other bots, right? It was just an example of what you could do when something happens to a game. But we're going to leave the toxicity to all the League of Legends players out there. Just a joke. Okay, so once all that happens, the BWAPI client is going to get updated, and if we have somehow disconnected from the game, then we're going to break out of this loop, and the bot is going to stop. Okay, so that is sort of the architecture for how our code interacts with the Broodwar API. Now what we're going to do is we can see here that all of these events actually trigger functions within our bot. So let's go look at the bot class now, because that's where all of our code lies. Now, to keep in mind, this is just one possible way of doing it. You absolutely do not have to have a bot class that has member functions triggered on these events. You could literally write all of your code within these events if you wanted to. I think I'm a big fan of object-oriented programming. I'm a big fan of data encapsulation and putting things in functions and code modularity. So that's why I've put everything into this bot class to make it easier for most people to work on the game and to do bot programming. So first, let's have a look at the StarterBot header file. So this will tell us what this bot looks like. Okay. So the StarterBot class just has one internal variable for now. It has one member variable of type mapTools. We'll get into mapTools later. Just be aware that it currently has one member variable. The public functions that we have are the constructor. Of course, our constructor has to be public. We have, all of the event-based functions that we just talked about, like onStart, onFrame, onEnd, etc. That's where most of our code is going to go. And then we also have any additional functions that you want to write in your class. And I have actually included these inside the bot. And if you're actually doing proper object-oriented programming, this bot should be the only person calling these. So these should actually be private member functions. Okay, so I'm just going to move those over there. If they're public, it doesn't really matter. No one is really going to have access to the bot's variable in order to change these things. But, you know, these things should be probably private. So that's what the bot looks like. And now we can go over into the bot and actually start doing some programming. So what happens when a bot starts? Well, here is our onStart function. So the very first thing that we're going to do whenever the game starts, this is what we're going to have here. The first thing that I've done is this function called setLocalSpeed. Now I'm going to run the bot in release mode from now on because I want it to be as fast as possible. So just as a heads up, debug mode and release mode run at very different speeds, but they're used for different things. So if you are debugging your bot and you want breakpoints and memory checking and all that, you're going to use debug mode. But all of that extra functionality is going to slow down your bot considerably, okay? So only use debug mode when you're debugging or doing development. When you actually want to run your bot, go to release mode because it'll be much faster. So I've chosen release mode here. I've hit my hotkey to run. Now, if I'm in release mode, I don't have to run it from here. It's actually a little bit annoying to do that, so I'm actually going to run it from here, which I've done. So you can see here that inside the game, my bot is actually running faster than a human would play the game, right? And the reason for that is because BWAPI lets us set the speed of the game. Now, it also has a very convenient function within the game called the /speed command, which lets me set that. So let me turn the speed to 100. So the speed variable, this setLocalSpeed function, okay, setLocalSpeed, takes in a parameter, which is an integer. What that integer does is it sets the minimum time per frame to that amount. So if we set that to 100, then that means each frame of the game has to take at least 100 milliseconds. Okay? So if it's 100 milliseconds, then that means we're running at 10 frames per second, and you can see here that the game is running at approximately 10 frames per second. If I want it to run at 5 frames per second, then I would take 1,000 divided by 5, which is 200, and I go /speed 200. So me typing /speed in the game calls this setLocalSpeed function in the BWAPI interface. So that's what that does. Okay. Now, if we want to play the game as fast as possible, right, if we're not actually watching it, but we're just maybe doing some testing or benchmarking on the AI, we can say set speed 0, which means the game will run as fast as possible. So as fast as our code runs, the game will actually run. And you can see here that the game is running at maybe like, I don't know, 200 or 300 frames per second, like that, something like that. And it's just running as fast as possible. And you'll see maybe the AI will come kick my butt now in a second. So that's what the setLocalSpeed option does. And if you really want to run as super fast as possible, there's also this command called setFrameSkip. And the integer argument into here means that it will skip that many frames of rendering. So if you do setFrameSkip 10, it will only actually render every 10th frame of the game, saving you even more time. So if you want to run your bot as fast as possible, you could do something like setLocalSpeed 0 and then setFrameSkip some large number. Okay, you don't want to make it too large, but setFrameSkip maybe even something like 32, so you can maybe see like what's happening every second in the game. Okay. Now, I do want to mention, before I go on, that these functions are being called via the BWAPI Broodwar game object. So, what is this BWAPI Broodwar? What's happening here? Well, everything inside the BWAPI library is inside this BWAPI namespace. And a lot of the functionality is going to be done on different classes. And the main class that controls the entire game is the BWAPI game class, and there is already an instance of that game that's set up for us inside BWAPI called BWAPI Broodwar. So there are many functions on this BWAPI Broodwar. If I come back over here to my Firefox and I type in BWAPI game, the first hit should be the BWAPI game class reference. So if I click on that, here are all the functions on that BWAPI game class. So if you look here, here is the set local speed that I just called. And so I can click on this and see all the details about the set local speed function. I can also go up and I can say, what was that other one? Set frame skip. If I want to know exactly what set frame skip does, I can come over here. So if you want to look at all the different things that you can do with the BWAPI game, then you can go Google BWAPI game and you can find that out. Also, something that you may want to do is one of the first things you do on the start is enable a few different flags. So there are different BWAPI flags. One of them is user input. So what this does, if I can show you here, is that while I'm running the game, I can actually issue commands to the units. And this might help me with some debugging. Like, for example, I can move these units around right now, etc. I can issue commands or build units, and it went back. So as soon as the worker went idle, the bot took over again. But that's a very useful function to have, and so that's why I've included it there. If you do not turn that on, then you are not able to control the units while they're playing inside the game. Now, another thing that I did was call the onStart function of my map tools, but I'm not going to get into the map tools just yet. Okay. Now, the opposite of onStart is onEnd. So what actually happens when the game ends? Well, what I've done here is I've just included for you a very sample function, which is onEnd, and the bool is winner. So I'm going to print out we, and then if we won, it's going to say we won, and if not, then it's going to say we lost. So for example, if you're trying to test out your bot and you want to run like 1,000 games overnight and record how many of those games you won and how many of those games you lost, you can use this function to say append the result of your game to a file to be able to record those statistics. And as part of the project for this course, so I'm giving this lecture as part of a course, so you can ignore this if you're not part of the course, but as part of the course, I do want you, as part of your project, to be able to play against the default AI and record how many games you won or lost against the default AI. And so this function is where you would implement that functionality. Now, I'm not going to get into onFrame just yet, because that's where we're going to spend most of our time. So I'm going to skip down to the different triggered unit functions. So here, for example, is onUnitDestroy. So if I want to do something in onUnitDestroy, let's say I want to print a message in the game whenever a unit is destroyed. So what I could do is this function is going to be called when a given unit is destroyed. So if I want to print something to the screen, what I can do is BWAPI Broodwar send text, and now I can say unit get type dot get name. Now, what is wrong with this? Okay, I see. So this is something that's a little bit annoying. The BWAPI Broodwar send text function and many of the string-related functions inside BWAPI, they operate on const-char pointers, and the getName function returns a reference to a string. And so the string to const-char conversion is not automatic, so we actually have to get at the raw string pointer in order to print it to the screen. So let's compile our bot, and we'll see what happens now. It's just going to print the name of the type of unit that was destroyed whenever a unit is destroyed. So I'm going to go back now that I've compiled it, and I'll rerun it. And I'll kill one of my own probes in order to show you what is printed out to the screen. So you can see here, Protoss probe was printed out to the screen whenever I killed my probe. And now what I'm going to do is I'm going to attack my own Nexus. And when my Nexus is destroyed, you should see Protoss Nexus printed out to the screen. There you go. And I was actually killed. So it printed out that we lost. See over here? It's a little bit small. Printed out we lost, and since I had auto restart set to true, then it started the game over on the next map in the map sequence. Perfect. So similarly, if you have onUnitMorph or onSendText or onUnitCreate or onUnitComplete or onUnitShow, that's how that works, okay? Is you get a pointer to the unit that thing logically happened to, like the unit that we saw that was destroyed, and then you can do things like maybe update data structures or print things or go to attack or whatever. This onSendText is a really powerful functionality for bot debugging and for doing stuff in your bot. So what this does is whenever you type in the in-game chat, then you can parse that text and do different things. So one thing that I've done is if I type /map into the chat text, I will trigger my map tools map drawing functionality. So I'll explain what that functionality is in a bit, but I just want to show you what that looks like. So here, if I type some random thing like /Dave into the chat, nothing is going to happen. But if I type that exact string /map, then I've toggled my map drawing functionality. So you can use your onSendText function to implement some debugging or features into your bot if you really want to. Okay, so that's a very useful thing that not many people take advantage of. Like, for example, if you wanted to have the ability to send all of your units to attack the opponent at some given time to see how your bot would do, you could say, like, if text equals /attack. Now, it doesn't have to be slash, right? It could just be attack or whatever you want. Then you could send all of your units to attack, and that could be a way that you issue commands to your game in a really sort of compartmentalized way without flooding your bot with hard-coded attack timings or something like that. Okie dokie. So those are sort of the secondary triggered functions, but the main one is this onFrame function. So what this is going to do is every frame of the game, you're going to be checking your units to see if they're doing what you want them to do. You're going to be sending things to build stuff. Maybe you're going to be scouting your opponent. All of that stuff is going to happen inside this onFrame function. So what I'm going to do is what I have so far inside the bot is these functions. And you can see here that, for example, I have a tool which I've written that draws the unit health bars. So let me just comment that out for a second, because I want you to see that we've been running. Oh, sorry. Let me also comment out draw debug information. So this is going to be drawing nothing extra to the screen. And we're compiled. Now we're running. So this is what StarCraft looks like by default. There are actually no unit hit point bars drawn to the screen, and there's no option for that. So if you're used to more modern games, only if you click on a unit or select a group of units will it actually draw the hit point bar. So what I've done is I've included functionality in there, and I draw my own custom hit point bars above the unit so you can turn that on if you want. But I've turned this off here just to show you that it is a little bit annoying not to be able to see without selecting a unit what the hit points of that unit are. So we're going to turn that back on. Okay, so let's see what the bot does. I'm a big fan of whenever I'm creating an AI system, that my main overall function, like for example, my onFrame function, I want that to look to me, it should read like a story. It shouldn't read like code. Now, people can disagree with me all they want, but large AI systems are difficult to keep all in your head, right? So if I was looking at this function and it was just 300 lines of code, it would be kind of difficult for me to understand in my head what was happening inside that function. So what I've done is I've separated different functionality into different functions that are all called from the main onFrame function, so you can see at a glance what the logic flow of the bot is. So the first thing that we're going to do, and the bot doesn't do much, but here's what it does. First, we're going to send all of our idle workers to mine minerals so they don't just stand there. Then what we're going to do is we're going to train additional workers so we can gather more income. And then the next thing we're going to do is we're going to build some more supply if we're going to run out soon. Okay? So that's all the bot does, is it, it builds more work, or it sends the workers to mine minerals, it trains additional workers, and it builds some additional supply. So let's just go through this, and I'm actually going to delete the code that I have here so I can go through it with you, and we're going to rewrite it because I like writing the code as I go so I can explain it as I'm writing it. That's how I learn better, so I'll do that with you as well. So let's just comment out the rest of the stuff here, and we're just going to draw the unit health bars, and we're going to send all of our idle workers to mine minerals. Okay, that's the first thing that we're going to do, and the only thing that our bot should be doing. Okay, so if you watched the video, which was sort of the intro to StarCraft AI, which I highly recommend if you didn't, then it showed you essentially how to do this, right? So if you want a more detailed explanation, you can go watch that video. But essentially, I just want to show you here kind of a flavor for how the Broodwar API works and the different classes and code that you're going to be calling. So the first thing I'm going to want to be able to do is I'm going to want to loop over all of my mineral workers, right? I'm going to want to somehow issue commands to various units that I control. So what I'm going to do down here is I'm going to write a for loop over a bunch of my workers, or sorry, over a bunch of my workers. However, you can't just say loop over all my workers. There's a little bit more that you have to do. What we can do in the game is one of two things. We can iterate over every unit in the game, or we can iterate over every unit that I control. So for example, I'm going to say auto pointer units equals BWAPI Broodwar get all units. So BWAPI has its own custom vector called a unit set. And so this is a BWAPI unit set of units. Why is this? Oh, this is a const BWAPI unit set. All right, so we've got a unit set of units, and if I call BWAPI Broodwar get all units, then it now contains every unit in the game. However, with an additional caveat, so this is important. The get all units function, units will contain every unit in the game that is visible to our bot. This is very important. So when you start the game of StarCraft, actually, let me start it up now. You can only see your units or anything around your units. Okay, so let me set the speed to like 100. So right now you can see that almost the entire map is covered in the fog of war, right? As I move my units, make it a bit faster. As I move my units, they uncover areas of the map that I can see. So the BWAPI Broodwar get all units function, that would be kind of unfair if it returned, say, for example, all of our enemy units, right? If that returned all the enemy units that we can't see, then this function, this interface would be so powerful that, you know, it would essentially be cheating. But the good thing is it doesn't cheat. So this will return the set of all units that we can currently see, which is important. However, now what I could do is I could say for auto unit in units. Now I'm looping over every unit in that unit set. Well, let's say, for example, I only want to look at my workers. So what I'm going to do is I'm going to filter out all of the units from the unit set from this iteration that are not workers belonging to me. So first thing I can do is let's filter out the units that are not mine, okay? And the way we're going to do that is by using the BWAPI player pointer. So we can say const BWAPI player me or self equals BWAPI Broodwar self. So BWAPI Broodwar self is how we get a BWAPI player object. It's actually a pointer underneath, so we don't need to use references. That refers to me. Okay. So if I go back over here and type BWAPI player, there's a bunch of functions on the player that I can call. For example, I could call get the units for a particular player. I could see whether or not they're an ally. I can see whether or not it's a neutral player. I could get the race of that player. I could get the gas of that player. I could get the minerals of that player. Actually, that's something that I can only call on myself. I could get their supply and their total. So this BWAPI player class is very important. So if I want to know if the unit is controlled by me, I can get the player of the unit. So that is the person who is controlling that unit. And now I can compare that to whether or not it's me. So you don't need to have this variable here. You could just call it like this. You could say unit get player equals BWAPI Broodwar self. So if the unit belongs to me, now I want to check if it's a worker, right? So the way I do that is by getting the unit type of a unit. So BWAPI unit type is also a very important class, and you'll be using this quite often. And the unit type class gives you access to all the properties of unit types in the game. So as I explained last time, unit, this is an instance of a unit in the game. So it's a particular marine or a particular supply depot or a particular worker, right? The unit type is like marine or probe or nexus. It's the type of unit. So if I say BWAPI unit type equals unit get type, now this will contain the information about that type, and I can say if type.isWorker. Now this is a worker unit controlled by me. All right, so that's how I would get access to the specific units of a given type that I wanted. So for example, if I wanted to get all the Marines of my opponent, I could say, well, if unit get player is equal to enemy, then I could say if type. Now, if I want to say a particular type, there's luckily a BWAPI unit types namespace, which contains all of the unit types. So I could say if, so here we go. Oh, sorry, 1 second. Now, this unit is a Marine controlled by our enemy. See how that works? So you go through, you filter it. It's pretty intuitive, but I just wanted to type it out so that you would get an idea for how easy it is to actually find the units that you want. Now, of course, if you were doing this a lot of the time and you say wanted to get all of your workers very often, then what you could do is you could write a function that maybe returned a vector of the units that were workers belonging to you. But let's do this sort of the proper way now, where I would say something like this. Okay, I'm going to delete all this, and instead of going over all the units and having to check to see if it was my unit, I can actually very handily query all of the units that only I control. So if I say BWAPI Broodwar self, remember, that's the player function, right? That's the player class. And then on that player, I can get the units. So now these are loop over all the units that only I control. So what I can do down here now is say, well, I want to do something if it's a worker. Now I could say if it's a worker, put some code inside, but I think it's actually a little bit cleaner to do something like this. So if not unit get type dot is worker, continue. So I prefer to have one line of code that filters out units, and then rather than have an if statement and then indent a bunch of my code. Okay, so that's why I've done it this way. So if it's not a worker, we don't care. So skip it. Okay? Alrighty. So let's just say now, if it's a worker, what I'm going to do is I want to send it to a mineral patch, right? I want to send it to a mineral patch in order to mine those minerals. So, okay, now I'm going to somehow have to get a mineral. So what I've done is I've written a function over here in the tools. So now I'm going to get into the tools that I've written, which you can use inside StarterBot. And one of those tools is get closest unit to. Okay, so what does this function do? What it's going to do is you pass it in a unit and you pass it in a unit set, and this function is going to return the closest unit inside the unit set to the unit that you care about. Okay, so let's look at how that function works. Okay, first what we're going to do is we're going to look at get closest unit to a particular position and a particular unit. So I just had, excuse me for a second, I had a question in the chat. Is there any unique ID associated with a unit? That is a very good point. Let me show you something really cool that we can do. Yeah, I think this is actually a good thing that we can do as a demonstration. So yes, every unit in the game has its own unique integer identifier. So what I'm going to do here now is I'm going to print that unique integer identifier onto the map, wherever that unit is. This is actually a really good example of how to go through units. All right, so I'm going to say auto units equals BWAPI Broodwar get all units. So now we've got all the units. I can say for auto unit, or I'll say u in units, int id equals u get id. So every unit in the game has a unique integer identifier associated with it. Now, let's say I want to do something for debugging purposes where I want that unit ID to be displayed on top of the unit while it's moving around in the game. So how would I do that? Well, there is a function in BWAPI Broodwar, draw text. So before we sent text, if you say send text, that acts as if you had typed that into the chat. However, draw text is a function that draws text onto the screen for that entire frame. So if you call it every frame, that text will permanently be on the screen at that location. So there's a number of different types of drawing text. One is just draw text. One is draw text map. One is draw text mouse. And one is draw text screen. So draw text map, whenever you draw text at a given position, it's going to be drawn on the map at that position. So for example, if you drew text at 0, 0 on the map, it would be in the top left corner of the map. So if you're not looking at that part of the map, you won't see it. Draw text screen, on the other hand, will draw it at that location on the screen. So if you draw text screen at 0, 0, then you will be drawing text always in the top left-hand corner of the screen itself. So wherever you look at on the map, it will always be there on the screen. So if we want something to be displayed on top of a unit, we want to draw text map so that it's going to be on the map where the unit is. Okay, so draw text map is going to take in a position, and it's going to take in a printf formatted string. So the position we want is unit get position. Okay, so we can get the position in pixel coordinates of the unit. Now, there are 3 different types of position in Broodwar API. One is a position, which is pixel-based. One is tile position, which is a build tile, 32 by 32 pixel resolution. Another is a walk tile. If you didn't watch the previous video, I have an entire section with slides explaining that. So please go back and watch the section on the grid system in StarCraft in order to understand the different types of positions. So we're going to draw it at the unit's position, but this is U position. And now in order to draw an integer, I'm going to do %d, and then I'm going to draw ID. Okay? So this will draw, and this format is just like printf. So I can say unit : if I want ID. And now I'm going to compile this. So it's compiling. The reason this is so slow is because it's in a virtual machine, so I apologize for the compile times on the stream. Now I'm going to go back and I'm going to run things, and if everything went well, then on every frame, I'm going to be drawing the unit's ID right next to them. So you can see here it's a little bit small, but this says unit 9. this is unit 7. My nexus is unit 16. You can see that even the Vespine Geyser has a unit ID, and all the different minerals have a unit ID. Now, there's actually an advantage that you have as a bot player over human players, and that is if a unit of the enemy comes in and out of the fog of war, its unit ID will actually stay the same. So you will know if the Marine or the Zergling or whatever that you saw before that was then hidden is actually the same Marine or Zergling that you saw originally. So that's a little bit of an advantage that the bot has, but you know, no one is really abusing that for any nefarious purpose. Oops, I just tabbed over, so that's an annoying part. So you may have saw some of the unit IDs of the enemy there. So if we want to do things like you know, print unit ID to the screen or any sort of information on top of a unit, that's how we would do it. And that's how I did the unit draw health bars, is instead of saying BWAPI Broodwar draw text, I said BWAPI Broodwar draw box map. Okay? And draw box map is, let's do a different example of draw circle map. So if I wanted to draw a circle, let's say at my start location, right? So how would I do that? Well, if you ever want to get your own start location, there is a function for that. BWAPI Broodwar self get start location. Now get start location is actually a BWAPI tile position. So I want to convert that to a position because they are different types. So watch the other video. So this is start pause, and I'm going to construct it with a tile pause in order to convert it to a position. It's just annoying. So start pause is the circle, and now draw circle map is going to take in some different arguments. So start pause, and now it takes in the radius. So let's draw a radius of size 10 or like 16, or screw it. It'll be 2 tiles wide, 32. It's going to take a BWAPI colors red, so it's going to be a red circle, and it's going to be a solid circle. So we're going to draw a rather large solid red circle at our starting position on the map. Oops, I didn't want to run it from there. I'm just going to let it compile. Then I'm going to come back and I'm going to run the batch file. Here we go. So now we have a rather large red circle at our starting position. So you can get lots of cool information about the game that's running. So we just look over, and the BWAPI game class will have a lot of that information. BWAPI player, so we just use the get start location, right? So get start location returns a tile position, which is the position of the start location of a given player. Now, we cannot use that on the enemy unless we've seen them, right? So BWAPI is kind of intelligent in that you cannot use, say, BWAPI Broodwar enemy start location to actually see where the enemy is. So actually, let's see what happens if we do that. I want to show you that. So let's, instead of self, take enemy get start location. So what will happen when we do this? Anyone out there have a guess for what will happen? I'm not sure what will happen, actually. I've never done this. So we're going to run it again after we've compiled it. Okay, we are playing on Tau Cross. And where is that dot? I don't see it. Okay, so it's like an invalid location, right? We cannot do that. But what I'm going to do is keep going until I get a 2-player map. Is this not going to do it? Q? Yeah, so this is a 2-player map. Okay, so even on a 2-player map where you could know where the enemy is, it is not drawing the enemy start location. So it lets you get access to your own location, but not the enemy location. So it doesn't let you cheat like that. Alrighty. So I've gone a bit longer than I wanted to. So what I want to do now actually is let's erase a bunch of this code and just go back to the code that was in there with the StarterBot. Please go back far enough. Okay, so we are back to the original version of the StarterBot, and rather than code it by myself, what I'm going to do is I'm just going to go over what I had there and explain what I had. So in order to send our idle workers to minerals, what we did was the following. So first, we got access to all of the units that we control. Then we're going to loop over all of those units, and we're going to say if the unit is a worker and the unit is idle. So an idle unit is one that's not doing anything. This is a very useful function. So if a unit is idle, then it's just standing there literally not doing anything. If it's moving or attacking or gathering minerals or building or anything, then it's no longer idle. So what I do is I want to send that unit to the closest mineral patch to it in order to start mining. Luckily, there is a BWAPI Broodwar function, getMinerals, which will return us a unit set of all the minerals. So the closest mineral to that worker, I'm going to use tools, get closest unit to unit BWAPI Broodwar getMinerals. Because this get closest unit to function, it returns the closest unit from this set of units to this unit. Okay, so this is a function that I have written for you. This does not come with the Broodwar API. And if that closest mineral is a valid unit pointer, because it's possible that I don't find a mineral, right? So that might be null. So we always have to check if this is null, and we can do that just by saying if, because that checks if it's not 0, which is null. So if it's not null, then we're going to send a unit command, which is to right-click the minerals. So there are a bunch of different unit commands that we can send. Right-clicking is the most basic one, and it'll either move you to a location if you've clicked on the ground, or it will start mining minerals if you right-clicked on the mineral, or it will attack an enemy if you right-clicked on an enemy. So let's just go over to tools once more to show how you would write a function like get closest unit to. So this is going to take in a position and a set of units. So this is just really basic for loop. You should know how to do this. You might be rolling your eyes already. So we're going to record the closest unit. And what we're going to do is say for each unit, if for each unit in the set of units that we passed in, if we don't have a closest unit set yet, or if the current unit is closer to P than our closest unit so far, then we're going to record that unit. So essentially, we just go all through all the units and we find the closest unit. And then we return that closest unit. But you can see here that if this set was empty, we would be returning a null pointer, so make sure to test all your unit pointers before we use them. But the function that we called passed in a unit. So what I've done here is I've written the base functionality on a position, and then if I want to pass in a unit, then this unit just calls its own position and calls the get closest unit position function. Super simple. Okay, so that's how you would send all of your idle workers to go mine minerals. The next thing that we want to do is train some additional workers. Okay, so this is where we would actually send a command to our Nexus to build an additional worker. So let me just run the bot again, and you can see that right off the bat, what happens, oh, I haven't recompiled it yet, but what would happen is I'm going to, if I have 50 minerals, right, I'm going to click probe, and that will train an additional worker for me. So that's what I want to happen. So here, I'm going to recompile. So how do I train additional workers? What would you do in order to do that? Well, this is where things start to get a little bit more complicated. But here's what I've done in the bot as a very, very base example. So the first thing I need to do is I need to get the type of worker that my player controls, right? Because worker is not a unit type. Probe is a unit type. Drone is a unit type. Terran is SCV is a unit type. So I'm going to get the particular worker type of the race of the player that I control. So I say BWAPI Broodwar self, that gives me the player pointing to me. Then get the race of that player, that gives me the race that I'm controlling. And then get worker is going to return the worker type of the race that I control. Now, what I'm going to do is, let's say I want to make up to 20 workers. Okay, so just keep making workers until I have 20 workers. So what I'm going to have to do is I'm going to have that count of units, say 20, but I'm also going to need to know how many workers that I already have, right? So what I've done is I've created another tool here which will take in a type of unit, and it will take in a set of units, and it will count the number of units of a given type within a set of units. Now, I'll just go over to tools really briefly, and counts unit of type, I do not need to go through that, right? I just have a sum, I go through each unit, if the type matches the type, I increase the sum. So I just increased I wrote a little helper function for that, just to have that so I don't need to write a for loop every time I want a unit count. So it's going to say, if the number of workers owned is less than the number of workers that I want, then I'm going to build another worker. That's really, really simple. So what I have to do in the Broodwar API interface, your Nexus, hatchery, or command center is called a resource depot. So in order to issue a command to build a worker, I'm going to have to get access to the unit pointer of my actual Nexus. So in order to get access to the unit pointer of the Nexus, or my depot, I've written another function, which is just called getDepot. So let's go look at that function. So my getDepot function is going to call my getUnitOfType function. So I've written, again, this sort of layered functionality where I have a function that can give me any unit that I have of a given type, but I want to get my specific race's depot type. So again, I call BWAPI Broodwar self get race and then get resource depot. And that will give me the type of the depot that I have to get from my own units. So then I'm going to return get unit of type with the depot. So up here, my get unit of type function, I'm sure you could all write this by now. I'm just looping over every unit. I'm looping over every unit that I control. So BWAPI Broodwar self get units. If the unit is of the given type and the unit is completed. So what is completed means is that, let's say I had another Nexus, but it wasn't finished yet, right? It was still in the process of being constructed. Then I want this function to only return a completed Nexus for me. So what I do is, if the type is correct and the unit is completed, then I return the unit. Now, maybe what you would want to do is put an extra condition to say, if the unit isn't currently doing something, right? So you could say, if the unit is not training something right now, but I'm keeping it really basic. So what I'm doing is I'm saying, okay, my depot unit is my depot. I only have one at the beginning of the game. So if we have a valid depot unit and it's currently not training something, then train a worker, okay? So what this does is the following. Why did I say and not training? Well, I'm going to go back to the bot. StarCraft has a unit queuing system, okay? You can see here that while I'm building this worker, there's 2, 3, 4, 5. Now, as a human player, if I wanted to do something like, hey, make 3 workers, then what I would do is I might queue up 3 workers in a row. So I could do something like this. See how down here there's a unit queue? So that is something that a human needs in order to take some of the mental and physical load off, is to be able to queue up units. However, you can see that when I queue up a unit, it actually takes the resources for that unit. So I don't want to queue up any units as an AI system because it's a waste of resources. So what I do here is I can make sure that I'm never queuing up an additional thing by saying, okay, make sure that it's not currently training something. And then in order to train it, I'm going to say my depot train worker type. So if you have a building that can build a type of unit, like a barracks would build a marine or a gateway would build a zealot, then you have to have the unit pointer to the type of the unit, the building, and then you say train, and then you give it the worker type. And what will happen here is that if you have the correct amount of resources, it will train it. And if you don't have the correct amount of resources, the command will basically just do nothing. So if you really want to, you could say, actually, let's just do that as an example. Okay. So I'm going to say, if BWAPI Broodwar self minerals is less than worker type dot get, or let's say mineral price. Okay. So if at any time in the game I'm trying to build a worker, but I don't have enough minerals, I want to print something to the screen. So I'm going to say BWAPI Broodwar draw text screen. Not enough minerals for worker. And that actually takes a position, BWAPI position, and let's draw that at 100, 200, for example. Okay. So let's compile this and see what it does. So if you are writing a more complex build order production system, you will, of course, need to be looking at things like the mineral price and the gas price of units. So we'll run the bot. Okay, so you can see here, if I just pan over a little bit, that we have not enough minerals for a worker whenever we have less than 50 minerals. See how that works? All right. So that's how you would do something like that. However, that's not super important for right now. But that's how we keep training workers if we want to. Okay, so this is a function that would train workers over and over again. One more thing I wanted to talk about was building units. Okay, building units. Oh, sorry, someone had a question in the chat here. Does a newly trained unit have an event fired? Yes, so let's actually do that. So we can say onUnitCreate. So onUnitCreate, what we're going to do, BWAPI Broodwar send text. So again, send text is just printing a temporary message to the chat. And we're going to say unit created. And then we're going to print the string of the unit type. So that's unit get type dot get name dot c string. Perfect. So now whenever a unit is created, we should be printing that out to the screen. Okay, that's compiled. We'll run our bot again. All right, so we can see here that we've discovered something, that at the beginning of the game, all of the units get created on the map. You saw that? It printed out all the minerals. So just keep in mind that that can happen as well. But you can see here, whenever we're creating a new unit, that function is being called. Another thing, if you can see here, all my workers, before they're constructed, are actually active on the map. So the unit gets placed underneath the nexus in the middle of it, and you can see this little, like this would be invisible if we didn't have this debug drawing on, but with the debug drawing, you can see the outline of that worker, and you can see its hit point bar. So that's pretty interesting, I think, is that the unit is there. So you always need to be checking if units are completed before you try and issue actions to them. Okie doke. So what about building buildings? Training units is easy. How about building buildings? Because the next thing is build additional supply. So in StarCraft, let me just run the bot again. And this was all covered in the last lecture. But we have a supply up here. You see how it says 5 out of 9? So I have 9 supply right now, and a probe takes 1 supply. So for example, when I build my first pylon, I can't build any more because you need to construct additional pylons, right? Like that very famous soundbite. So I need to construct more supply in order to build more units, with the maximum being 200. So how would we do that in our bot? How would we construct more supply? Well, here's how we're going to do that. Okay, so first of all, we need to see how much supply we have. So the logic of this function is basically going to be, if we think we're going to run out of supply soon, start construction on a new supply depot, or a pylon, or overlord, for example. Excuse me. Okay. So the unused amount of supply that we have to first get our total supply and then subtract the amount of supply that we used. So if we have 5 out of 9, this will return 4, for example. However, the underlying game, if you see 5 out of 9, the underlying game actually records that as 10 out of 18. So the get supply command always returns twice as much as what's displayed in StarCraft. And the reason for that is that's how they implemented two Zerglings equaling 1 supply. So the way that they do 2 Zerglings equaling 1 supply is by actually having everything else be double the supply and only displaying half of the supply count. It's a bit of a hack. So what I said here was that if we have more than 2 unused supply, don't do anything, okay? So this actually means 1 inside the game. So if we currently have room left to build something, we don't need more supply, so don't build any more supply right now. Otherwise, we're going to continue with the function. So we're going to want to build our supply provider. And so what we do is we say, okay, well, our supply provider is, it's specific to our race. So we go BWAPI Broodwar self get race.get supply provider, and that will provide us with the unit type of the supply provider, just like we did with the worker and we did with the depot. The only other function like this would be get refinery, I think. Get refinery, yeah. So each race has its own refinery unit type, and there's a function there to get that as well. But we want the supply provider. And now this is where things get a little bit complex, is when it comes to building buildings, okay? So what I did was I wrote a function called build building. And that function is going to return true if the unit command was given to our unit to start building the building. So why will we need that? We'll see later, okay? So here is, let me go to the build building function. Alrighty, so build building is a little bit complicated, but not that bad. So what we need to do first in order to build a building is select the unit of the correct type that actually constructs that building, right? So inside a unit type, it will contain the unit type that builds it. So what we say is type.whatBuilds. Now, something that's a little bit annoying is type.whatBuilds is actually a standard pair which contains the type that builds it and the number of those type that you require to build it. And the reason for that is because there's one edge case of stupid Archons, and Archons take 2 Templars to merge together, okay? So what builds is actually 2 things. The first part of it, of that pair, is builder type, and the second part is how many you want. So that's why we call .get first. Now, once we have the type of builder, we are going to select a unit that we control of that given type. And we've already created that function. So this is modular code, right? We are reusing functions that we created earlier on. Now, if we didn't get a builder unit, then we can't build it. So we have to return false. Next, what we have to do is there is a built-in function into Broodwar which will get us a building location for a building. However, as part of that function, we have to pass it in where we would like that building to be built, and then that function will return us some nearby location that it is legal to build that building. And how this works is a little bit of a mystery. It's actually what the default built-in AI uses to build its buildings. So, excuse me, I've been talking a while. If we want to place our buildings, like build a wall in or a sim city or something like that, you have to construct your own building placement function. And that building placement function will be a little bit difficult to write. So for the time being, just to get something up and running, we're going to use BWAPI's built-in building placer. However, where do we want to build our buildings? Well, ideally, we want to build them close to our starting location, right? So this desired position is our starting location, and that's of type tile type. Now, we have to pass in a maximum building range because the algorithm that they use, it searches, I think, in some sort of spiral around the desired position up until a maximum building range. And this building range is actually in build tiles, so 64 is almost the entire size of the map, okay? So if you want to ensure that it's really close, put this down to something, something more manageable. You have to also say whether or not the building that you want to build requires creep, because Zerg buildings require creep, right? So it will only look on creep for creep if you have this set to true. So then what we do is the tile position, so the building placement tile position. Let me demo for this for you real quick. We'll run the bot again. I just need to wait for it to gather some minerals for me. So whenever we're building a building, it operates at this tile position. I need more minerals. Yeah, the bot is spending minerals as fast as I can get them. Okay. So you see here that if I want to build this pylon, it's going to occupy a 2x2 space of tile positions. They are 32 by 32 pixels each. This is more apparent if I try and build a nexus. Okay. Some parts are red and some parts are green. If it's all green, then I can build it there. So the BWAPI Broodwar get building location, this is what is being used to place these buildings right now. It's pretty dumb, but it works, okay? So you can use it for now. So the desired position is our start location. It's going to find a position around there. And then what happens is we're going to get our building position, and then we're going to tell our builder to build the type of unit that we want to build at that building location. This build command, if I mouse over it, it returns a bool. And it says returns true if the command was passed to Broodwar, and false if BWAPI determined that the command would fail. So the reason that a command would fail is if, for example, if we told it to build somewhere and it said can't build at that location, if we told it to build somewhere and we didn't have enough minerals, etc., etc. So this function, build building, will return whether or not the building was actually going to be completed or going to be started. So if we go back to build additional supply, we have started building, and then we print out whether or not we started building something. However, you see here that I have a tools get to supply total true. So why didn't I just use the built-in BWAPI Broodwar supply total, right? And the reason for that is the following. If I said, if unused supply is greater than or equal to 2, what will happen is that while my supply is building, I'm going to demo this again. So while I have a pylon building, I don't get the additional supply until it's finished, right? But I don't want to build 10 supply depots while one is constructing. So just watch. When this is done, now I get the additional supply. And now, when I get to 16 out of 17, it should build the second one. So let's hope that that works. But what it's not going to do is continuously build supply. Oh no, the Zerglings! Attack back. Oh, I died. But essentially, you can see what I'm saying, right? While the supply depot is building, we don't have the supply yet. So we don't want to build 10 of them when we only need 1. So what this does is it gets the total supply that we have, including constructing resource buildings. So let's just go look at that function real quick. And that is get supply total. So what I'm going to do is I'm going to start out with the total supply that I control. So that's the supply total. That would be the 9 at the start for Protoss. So I got this bool here, which I pass in. And if this is true, then I want to count any supply that is currently being constructed. If it's false, then I don't want to count any supply being constructed. So if this is false, I don't care about any supply in progress, then I'm just going to return the total amount of supply that I have. Otherwise, if we do care about the supply in progress, I have to go through all of my units to check for uncompleted units and then add to the total the amount of supply that they would provide if they were actually constructed. So what I do is I go over each of my units, and if the unit is already completed, then it would have added its supply total anyway, so I need to ignore that, right? I'm just going to go on. However, if the unit is not completed yet, then I'm going to add to my total supply the supply that would be provided by the type if it was completed. See how that works? And the other thing that I have to check is that not only if I have a supply building in progress, but if I currently have a worker on the way to build a supply building. Okay? So how would I tell if a worker is on the way to build a supply building? Well, I check the unit's last command. So for each of my units, I'm going to say, okay, get the unit command that was last issued to that unit, right? If that was a build command, then it will have a parameter of a given type. So if the command's type was equal to build, right? So if the last thing I told this unit to do was build something, then what I'm going to do is I'm going to add to my total supply the amount of supply that would be provided by the thing that the command is trying to build. Okay? And the reason for that, I'll show you now. So if I put false into here and I didn't care about my supply that was in progress, let's see what the bot will do. So let's run the bot again, and we'll get to the point where it starts building the pylon. Okay. Ignore all that debug printing. That's just there from earlier. I should have removed that. So it's going to build a pylon in a second. But we don't have the supply yet. So this person wants to build another pylon, but I think it's trying to get there, but something's wrong. I think it's stuck in this mineral patch. Okay, that was a bad example. But yeah, it was stuck in the mineral patch. See how that worked? Now, I want to go to the next pylon, because I think at the next one, we're really going to see some stuff go down. So once we get to a certain amount of probes, it's going to want to build more pylons. Okay, so once we get to 24, it's going to say, I need another pylon, but we haven't done the in-progress checking. Oh, geez. Sorry, 1 second. And so we may see a bunch of pylons get built that aren't necessary. Hopefully we see that. Yeah, so it's trying to build a pylon here. Now it thinks it needs to build another pylon, so it warps it in. Now it thinks it needs to build another pylon, and it needs another pylon, and it needs another... So you see, that's why we did that, okay? We have to check for all those things that were not completed yet, or we're going to build a bunch of pylons. That was, yeah, so that's why we did that, and we're going to change that back to true. All right, now we've been going for a while here, but I just have one more thing that I want to go over, which is in tools, I believe. Yes, so I want to show you an example of something where, let's say, instead of sending our idle workers to mine minerals, we're just going to send all of our workers every frame to right-click on a mineral. Okay? So every frame, we are going to right-click all of our workers on our minerals. What is that going to look like? I mentioned this briefly in the last lecture, but I want to go over it again. Look, they're stuck. They're not doing anything. You'd think at least they'd be mining, but they're not. So what's happening is, in the game, if you spam right-click every frame of the game, you can bug out units in the game. So if you tell all your, like, some unit to move to a specific location on every frame, or attack a certain unit on every frame, or like mine a mineral on every frame, then that is going to bug out your units in this very, very real way. So the reason checking for idle worked is that the unit actually does begin. So as soon as it starts moving, right? Okay, so over here, as if I checked for idle, which I had been, what's going to happen is I'm going to see if the unit is idle, and then I'm going to right-click a mineral. At the point where it starts moving, it's no longer idle. Okay, so it's no longer spamming right-click. However, if this is a case where it's really easy to eliminate this problem because we have the idle check. However, it's not so easy in a lot of other cases, okay? And what we can do in order to eliminate that, I want to show you how to eliminate this check without checking if it's idle or not. And what we can do inside Tools, I have something which is called, I think I had it here, Smart Right Click, okay? So Smart Right Click, essentially what it's going to do is it's going to say that if I'm sending a right-click command with the same command as my previous command, then just completely ignore it, okay? So let's say that I want to right-click a worker onto a mineral patch. Well, first I'm going to say, okay, if there's no unit or there's no target, just return, don't do anything. Otherwise, don't issue a... Another thing we don't want to do is, let's say on one frame of the game, I told a worker to mine minerals, and then some other, maybe like scouting command or something came in and interrupted that command with a second command. So maybe what I want to check for as well is not to send a second command to a unit on the same frame of the game. Similarly, if we gave a unit the command to right-click a mineral, for example, and then on the next frame we tell it to right-click that mineral again, then what we're doing is we're checking to see if the last command's target is equal to the target we want to send it to, and if so, then we return. We don't want to send that command. So in the end, what we've done is, if we have a valid unit and we have a valid target and no other command has been given to that unit this frame, and the target we want it to go to is not the target we already told it to go to, then we can right-click. So down here where I said unit right-click, what I'm going to do now is the following, which is I'm going to say Tools, Smart Right-Click, Unit onto closest mineral. So I seriously hope that this works, because I didn't test this, so I'll look like a fool if it doesn't work. But here I'm no longer checking for idle. Before, it was bugging out and they weren't mining anything. So let's just see if they actually start mining now. And I hope they do. There we go. So they started mining. However, the internal command of the game, as soon as they go back to the depot, what happens is their last command was no longer right-click this mineral. Their last command was return to the depot. So this is a little bug that I've just showed you about, right? So what happens is we are correctly telling it to right-click. However, when it gets to the mineral, it mines it, it gets full of minerals, it wants to go back, its command is no longer set properly, and so we tell it to go back to the minerals. So this is here just to tell you, like, please be aware that this sort of thing can happen in your bot, and you're going to have to try for it. However, with the case of workers and minerals, it's very easily solved by saying unit is idle. So if we do that, that will solve our problems. Really quickly, one last thing. I sound like Columbo here, just one last thing. Let's see if there's any tools I wanted to go over. I'm not going to go over draw the health bars or draw the unit commands or the bounding boxes because that's pretty self-explanatory. It just goes through and makes some lines on the map. However, I did want to explain this map tools thing. So the way that you interact with the map, if you remember in the last video, if you haven't watched that video on the Starcraft grid system, that can be a little bit hard to get the information from Broodwar. Not hard, just annoying to call it all the time. So what I've done is I've just created these sort of 2D array grid structures which record information about certain parts of the map, okay? And we record like whether or not you can walk on a specific tile of the map, whether or not you can build on a specific tile of the map, whether or not you can build a depot on a specific tile of the map, like when the last time you saw that part of the map was, etc. And I've just included all of these helper functions here for you so that you can use these map tools as sort of a more optimized way to compute and look at the map in a way that's much more similar, if you are a member of Computer Science 4303, of the course, similar to previous assignments in the course. So if you wanted to do something like flood filling for vector fields in StarCraft, you could totally do it using this because now you know how to work with these grid structures. And I've included a feature here which is drawing, and I just wanted to explain that really quick because it can help you to debug your bot. So I'm going to type /map, and what it's going to do is for every build tile on the map, it's going to display the walk and buildability information for that part of the map. Now I went over this in the last class, but this is just sort of a live demo where I have whether or not I can build on specific tiles, whether or not specific tiles. So for example, if a tile here is red, this is like one of these, ooh, I found a bug in the bot. Look at that. It's going to different mineral patches. So the StarterBot is not completely optimal, that's for sure. So red areas of the map you cannot walk on and you cannot build on. If it's green, you can walk on it and build on it. If it's yellow, you can walk on it, but you can't build on it. So you can see here this ramp is yellow. So that's why, is because you can't build on ramps. If it's this teal color, then you can't build a depot there. So let me just show you how this matches up. So if I say build, oh, I can't issue commands because never mind. Build Nexus. So you can see here that you can't build depots on this teal area, and that's because StarCraft does not allow you to build resource depots within 3 tiles of a resource. So that is the map tools. It's just there for you. It also, it's kind of self-documenting, and if you go through, you can see how that sort of thing is done. And the last thing I wanted to do in the bot was to show you the code for scouting. So scouting is important. I'm going to create another function, and then I'll actually put this in the bot later, where we're going to just take one of our initial workers and we're going to scout with it. So let's turn off everything else that the bot does, okay? So it's not going to do any of this drawing. It's not going to do any of that. It's just going to send out a worker to scout. So I'm just going to put this directly in the onFrame function. So the first thing we need to do is we need to get our worker type. Remember, I've got this code down for this. So I've got a worker type. Then I'm going to use my BWAPI unit worker or scout equals tools get unit of type worker type. Okay. So what's going to happen here is I want to get a worker in order to scout my enemy, right? Because on certain maps, I'm not going to be able to see where my enemy is. I don't know where they are. So I'm going to have to send out a worker or some other unit to be able to scout it. So this is going to say, okay, what is my worker type? Let's get a scout of that worker type. However, I want my scout unit to persist from frame to frame and make sure that I don't choose different workers on each frame. And if I just use get unit of type, it's possible that if I make another unit, that just iterates through my units in sort of a random way that I might get a different scout. So inside my class, what I'm going to do as a class variable is I'm going to have a BWAPI unit, and I'm going to call it mScout, and that's going to be set to null pointer. So that's going to be my scout that I keep on using. So I'm going to get a scout unit. So I'm going to say if not mScout. So this says if I currently haven't got a scout worker set, I'm going to set my scout worker by doing this. So mScout. There we go. And I can eliminate this function call. Okay, so if I don't currently have a scout, okay, then someone said if not null pointer. Yeah, this works too. I don't need to do that. So you can do Boolean checks on integer pointers. This is just a shortcut to say this would be if the pointer is non-zero, this would return true. If the pointer is 0, this would return true. That's fine. I just wanted to make sure I wasn't making a mistake. And for those of you who forgot, I'm live streaming this, so I'm taking questions as we go. So if we don't have a scout, set the scout. Now, what I want to do is I want to scout an unexplored base location. So we went over this code in the last lecture last time, but I'm going to write it. So if I call BWAPI Broodwar get start locations, what does this return? Well, we can mouse over it, and this is going to return a queue. So I'm just going to say auto start locations equals get start locations. So now we're going to write a function over these. So for auto, let's say loc in start locations. So now we're iterating over each start location. So I don't care about start locations that I have explored. Okay? So I can say if BWAPI Broodwar. So a loc here, this is a tile position. So let me just be BWAPI tile position. I'm going to call this the position. So this is the tile position, I'll call it TP, of each start location. Luckily, BWAPI has built in for it is explored. So is explored takes in a tile position. And what we want to do is we say, if I have already explored that location, then I want to continue on to the next location because I don't need to worry about that location, right? Otherwise, what I want to do is send my scout to that location. So let's do that. But also, just so we can debug things, let's draw a red circle at the location that I want my scout to go to. So I'm going to have BWAPI position, pause. I'm going to convert the tile position into the BWAPI position, right? And then I'm going to send my worker to go there. But first I'm going to draw it. So BWAPI Broodwar draw circle map. Now it's going to be at pause. It's going to have a radius of 32, so it's nice and big. BWAPI color red, so I know that I can see it on the map, and I do want this to be filled, so I'm going to say true. Then what I'm going to do is I'm going to say M scout, right click, or I could say move, right? So move to that position. So right click and move give the same command. And so is this all I need to do? Well, I'm not sure. So this might be, oh no, sorry. Now that I've given a command, I actually want to break out of the loop. So I'm not going to, like, I'm not ping-ponging back and forth between base locations. Excuse me. All right, so let's go up here and we'll run it again and we'll see what happens. So nothing else should be happening in this bot, but what I have done, /speed 30, just so it's a little bit slower, is I've taken one of my units and I've told it to go to an unexplored start location. So look at this. So this is an unexplored start location. When it gets to it, guess what? Now BWAPI knows that it has been explored, right? So now that it's explored, it will go to the next unexplored start location, which is up here. See how that works? That's like, it's so clean and nice that it just works like that. So now it's going to scout up here. So it will get to this scout location. And I'm here, right? But now it's seen it, so it keeps scouting even though we've seen the enemy. So you might want to put something in there that says, okay, like we've seen that location, we've seen the enemy, we don't want to scout anymore. But anyway, that's how you would start to write a decent scouting algorithm. This doesn't, go into like avoiding the enemy or trying not to die or anything like that. It's just a very, very basic way of doing that. So that's really all I wanted to show you about the StarterBot, because I think that is a really great place to get started at writing your AI. And I've sort of shown you, how you can do these sort of complex behaviors and do StarCraft things. And it's not that difficult. Later on, when you start getting into like complex micromanagement and build order strategies and avoiding enemy units and flanking and stuff like that, yeah, it does get a little bit complex. But if you are interested in a more fully fledged bot that does all of those sort of things for you, then you can look for UAlbertaBot, which I've misspelled. Oh, geez. UAlbertaBot. Here we go. So you click on UAlbertaBot. This is a more fully fledged bot that if you go to my YouTube channel, there is a setup guide for this. You go to the wiki, to the installation instructions, and there's very detailed instructions. It's a little bit more complicated, but it's also a more complicated bot. So see that video if you're interested in building on a bot that already has a bunch of functionality rather than building a bot from scratch. So again, if you saw any links displayed here, like the GitHubs or BWAPI or whatever, those will be posted down below in the description. And also, for a more detailed explanation of StarCraft itself and strategies and some more detailed technical stuff, please see the previous Intro to StarCraft AI video. Thanks a lot for tuning in, and I'll see you in the next video.